sky never lied and brought me to the dark. One by one into the fire.
To the sky, the moon, and the stars. Traveling into space has long been one of humanity's greatest dreams. Just a century ago, spaceflight was pure science fiction. But with the invention of the first flying machines, we took to the skies, and the stars became the next destination. When we finally entered space, it was a triumph of science, but also a display of political power. Today, that has changed. In the 21st century, space travel is increasingly driven by the private sector, and Earth's orbit is no longer a distant frontier. It's a vital part of our global economic infrastructure.
Space travel has fundamentally changed over the past 20 years. Once space had been conquered, it was also used for scientific purposes, with the Space Shuttle and the International Space Station. The turning point came at the beginning of this century with a commercial company, SpaceX. It ferried cargo, astronauts, and tourists to the International Space Station. And then there were even suborbital flights just for tourists. Where will things go from here? NASA has divided space into two parts. What is known as cislunar space, meaning everything on this side of the moon. This is to be used for commercial purposes only. The moon itself and everything beyond, that is the region for national exploration.
October 4th, 1957. A man-made object orbits the planet for the first time in history. When the Soviet Union launched the satellite Sputnik 1 into space, it crossed through uncharted near-Earth territory. The metallic sphere, beeping its way through space, shocked the West, and especially the US. With a certain arrogance, the Americans underestimated the Soviets, imagining them more suited to building refrigerators than rockets. But the artificial Earth satellite now made the Soviet Union the world's first spacefaring nation.
Sputnik was a huge shock back then when the Soviet Union launched this satellite. People didn't even know whether it would work, that is, that an object could be launched into space, that a rocket could be accelerated in such a way that something could be brought up that would then stay there for a while with enough speed for a stable orbit, so to speak, and that radio contact could be established at the same time. Up until then, all this was unknown.
The development of Soviet rocket technology was top secret, and the identity of the rocket designer was just as secret. American intelligence services referred to the unknown designer as the Integral. Behind the name was the ingenious engineer Sergei Koroljow, the most important man in the Soviet space program.
Koroljow was already working on rocket technology before the Second World War. It wasn't during the Second World War that he learned that Germany was working on this as well. He was already aware of it beforehand and was working on similar projects himself. So on the one hand, he was a brilliant engineer, but he also projected this aura that he could manage it. And people followed him without having to have never-ending discussions about it.
Sputnik 1 marked the beginning of the space age and an early high point in the Cold War between East and West. This tiny orb, an artificial moon, was now orbiting the Earth, and it was red. The space race was already in full swing, and the Soviet Union had just scored its first major point.
Sputnik did little more than beep, beep, beep. But that meant you could send propaganda messages all over the world, and everyone could hear them, and there's nothing they can do about it. Suddenly you can broadcast all around the globe. You are untouchable. You can communicate, you can take pictures, and thanks to space travel, suddenly you're everywhere.
The USA experienced an even greater humiliation in this space race on April 12, 1961, when Vostok 1 took off from the Soviet cosmodrome in Tyuratam, today Baikonur, in southern Kazakhstan. The first human being had ascended into space, Yuri Gagarin. After orbiting the planet one time, the comrade cosmonaut returned to the Earth as a new hero of the proletariat.
I think that was the initial spark for the whole of space travel. People saw that you can send a person into space. A person can survive that. Humans can orbit the Earth. Everything that had previously just been assumed was confirmed in an experiment. In other words, Yuri Gagarin's flight showed that it's possible to transport people into space and bring them back alive.
Alan Shepard became the first American to fly into space 23 days after Gagarin's historic mission. The U.S. stepped up its efforts. The space program was given top priority. To catch up with the class enemy and surpass the Soviet Union in the space race, politicians set a clear goal.
There's a memo from Washington, from Kennedy to Vice President Johnson, essentially asking the question, what do we do now? The Soviets have done this and that. What do we do now? And there's a list of questions. Do we want to do this or do that? And then it turns out that the idea chosen was the boldest of all, to take people to the moon and bring them back safe and sound.
President John F. Kennedy announced the ambitious plan during a speech at Rice University in Houston, Texas.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
The American Apollo program was intended not only to put the first human beings on the moon, but also to regain technological predominance. Money was not an issue. The program devoured more than $25 billion US. The Saturn V moon rocket was a machine the likes of which the world had never seen before. And with Neil Armstrong and Buzz Aldrin's first steps on the moon, the space race was, for the time being, decided. That was July 21st, 1969, and after the Apollo 11 astronauts, 5 more manned missions reached the Earth's satellite. To date, 12 people have walked on the moon, all of them Americans.
What did the beginnings of space travel actually look like? The first to use rockets were the Chinese in the 13th century for military purposes. But their flight paths were relatively uncontrolled and lasted just about a kilometer. It would not be until the 16th century that Konrad Haas, a military engineer from Vienna, published a book presenting the best way to build rockets. The foundations for space travel were then laid at the beginning of the last century. The Russian Konstantin Ziolkowski published his famous rocket equation, and 20 years later the German Hermann Oberth published a book showing how to actually reach space with a rocket.
A trip to the moon has always been one of the greatest dreams of humankind. Scientists and authors had racked their brains over what might await us on Earth's satellite. In 1865, the French utopian Jules Verne described how people set off to conquer space in his novel From the Earth to the Moon. Jules Verne's adventurers leave the Earth using the means available at the time. A giant cannon shoots them into space. Jules Verne's novels also formed the basis for the 1902 film A Trip to the Moon by French director Georges Méliès.
If you do that and then want to reach the right speed, you might think that people in this space capsule would not survive. The acceleration would simply be too great, the so-called G-forces would be too great, and people would not survive. To that extent, he described it well. He described the journey itself perfectly, including the orbit around the moon. But he made a mistake in regard to the spaceship launch. Today, we know that you can only send spaceships into space with rockets, not with a cannon.
By the end of the 19th century, Russian mathematician and physicist Konstantin Ziolkowski was already thinking about how humans could actually conquer the moon and space. Beginning in 1885, he wrote several papers on the construction of space rockets and predicted the normality of manned space travel, long before humans had launched even the first object into space. And he realized that a multi-stage rocket powered by liquid hydrogen and oxygen could reach the speed required for a flight into Earth orbit. The rocket equation he formulated still forms the basis for all rocket developments today. Ziolkowski is considered one of the pioneers of space travel. He was also an avid reader of Jules Verne's science fiction novels.
Jules Verne got people excited about space, excited about flying to the moon, and also made sure that humanity thought, okay, what's actually the first achievable destination beyond Earth? And because Jules Verne described it so well, I think the moon really came into focus for the first time. And people said, that's where I want to go.
Hermann Obat, born in 1894, was also inspired by Jules Verne's novels. He is considered one of the early pioneers of space travel. Obat wanted to know whether Jules Verne's fictional description of a trip to the moon was actually technically feasible. And so he checked whether the author had correctly calculated the speed of travel to the moon. To Jules Verne, it was fantasy, of course. But the young physicist Obat clung to the feasibility of a trip to the moon. In his 1923 work, The Rocket into Planetary Space, Hermann Obat described the fundamentals of space technology and outlined models of space rockets. The third edition of the book, entitled Ways to Spaceflight, is considered the first standard reference work on rocket technology and space exploration. The physicist thus laid the theoretical cornerstone to make the dream of flying into space come true. The year was 1929.
When Hermann Obert's book came out nearly 100 years ago in the 1920s, he'd already figured out the physics. He also described the forces and masses involved and opened a completely new door. Until then, the heavens were something spiritual, something religious, something mystical. Suddenly, it was understood that our physics holds true there too.
After the publication of Hermann Obat's book, the first flight into space would have to wait another dozen years, until the global war triggered by Nazi Germany was nearing its end. The Aggregat 4, the A4, developed as a long-range weapon, reached altitudes of up to 170 kilometers, far beyond the generally accepted threshold to space at 100 kilometers. But the goal of the rocket that German propaganda referred to as the V2 was not to break records. The V in the name stood for Vergeltungswaffe, vengeance weapon, and the sole purpose behind developing the rocket was to deliver death and destruction, primarily to London and Antwerp. Hermann Obat was just as involved in its development as his student Wernher von Braun, who headed Adolf Hitler's rocket program and made the A4 ready to deploy. After the end of the war, the US and the Soviet Union acquired the remaining V-2 rockets, along with the services of many German rocket experts. Van Haffen-Braun and his team gladly accepted the invitation to the US. Other German scientists were forcibly deported to the Soviet Union. Now, the expertise acquired by the German rocket engineers in the service of the Nazis was enlisted for the two new superpowers' armed forces. In the U.S., Van Haffen-Braun's work finally culminated in his greatest triumph, the Saturn V, the moon rocket.
Apollo 11 marked the end of the moon race. 6 more moon missions would follow, but the Apollo program ended early. Why? The Americans had grown tired of the moon. They asked about the benefits of space travel, and NASA's answer was the Space Shuttle, a space transporter that would fly into space and back again. Its destination in orbit was a space station. Initially, this was the Russian Mir station. Then came the International Space Station. It was a completely new idea to make the space shuttle reusable as a way to save costs. But exactly the opposite was the case. The shuttle had grown so complex that it needed lots of repairs, and that drove up the costs. What's more, the weight of the shuttle was so high due to reuse that it became a cost trap.
An era in space travel came to an end on the night of July 21, 2011, when the Space Shuttle Atlantis returned to Earth. The Atlantis was the concluding chapter to a program that had always been controversial, too expensive, too fragile, and too unsafe. But it was also successful. The Space Shuttle completed 135 flights into space, transporting more than 800 passengers. The original idea was to have a reusable spacecraft that could be launched once a week, thus providing low-cost access to space. A logical but also unrealistic approach. At the time, there was no need for such a high number of launches. Besides, from the outset, the shuttle was planned for both civilian and military use. This increased the demands on the spacecraft, and the costs skyrocketed.
The Americans tried to come up with a solution that can do everything with the space shuttle. I can bring up satellites. I can bring up people. I can build a space station. I can do everything at once. If only it had worked in terms of reusability, cost-efficient reusability. But that's the thing that didn't work out.
The work to develop the orbital glider dated back to the Moon program. Transporting satellites and supplying space stations with crews and supplies would become routine. However, the fact that the Space Shuttle was also designed as a military spacecraft led to considerable additional costs. Hence, even years after the first launch in 1981, the only 5 space shuttles built did not work as planned, and they certainly did not cover their costs. It was not easy to fly into space with the shuttle. It was not cheap, and it was dangerous.
The costs were enormously high. It just wasn't sustainable for long-term implementation of flights and experiments. But NASA really does deserve a great deal of credit. They developed new technologies and showed us new possibilities. The shuttle flights created an opportunity to ferry astronauts into space to perform the first experiments that were later continued and operationalized on the space station. So after the Apollo flights, the shuttle certainly was necessary to prepare the space station and really get long-term use of the space station on the right track.
The shuttle never did offer the low-cost access to space its creators had hoped for. So the rapidly growing satellite market was dominated by conventional rockets. That benefited Europe in particular. Within just a few years, the multinational company Ariane Space, created with the backing of the European Space Agency ESA, had developed into the world's largest provider of satellite launches. Hence, the Space Shuttle was used mainly for scientific and military missions, especially to transport large satellites and, of course, as the backbone of manned space travel by the Americans and Europeans. One of its greatest successes was certainly the launch of the Hubble Space Telescope in 1990, when the Space Shuttle Discovery brought the instrument to an altitude of 600 kilometers above Earth. When it turned out that Hubble was unable to take sharp images, the Space Shuttle alone had the capability to set off on a repair mission that would rectify the defects. Space Shuttles returned to Hubble 3 more times, extending the service life of this exceptional telescope.
It was precisely because the shuttle existed that it was possible to carry such a large, complicated telescope into Earth orbit, deploy it there, and repair it. This telescope actually was repaired, and it's a great success story because it was the first telescope that could be used to conduct explorations without the Earth's atmosphere. The Earth's atmosphere interferes with optical observations because it always flickers a little and fluctuates in density. So this made it possible for the first time to observe without the Earth's atmosphere. And the second thing is that the Hubble Space Telescope can capture tiny amounts of light, which means very weak signals. Very weak signals are signals where the light has traveled a vast distance, and if it's traveled a vast distance, then that means the light comes from a very early time in the history of the universe. And that's why the Hubble Space Telescope was able to peer into a very early phase of the universe, for the very first time.
The Space Shuttle played a crucial role in the construction of the International Space Station, the ISS. Between 1998 and 2011, it completed a total of 37 missions to the ISS. The Space Shuttles transported the station's main modules and structural elements into Earth orbit. Its large cargo bay provided the necessary space for heavy and bulky components that could not be transported aboard conventional rockets.
It flew successfully for decades. We still have all the pictures of the shuttle before our eyes and the things it accomplished. And when you go to the museum in Florida and look at the shuttle, you realize what an incredible achievement it was. I believe it was important and successful. In the end, it failed because of money. That's something you just have to acknowledge. The shutdown of the shuttle program was economically necessary because too much money was tied up there. And you couldn't do anything new.
The American space shuttles shaped an era of space travel, despite the 2 accidents. After the program was discontinued, the 3 space shuttles that remained following the losses of the Challenger and Columbia became museum pieces. The space shuttle concept ultimately proved a dead end in the U.S. space strategy. With the last space shuttle flight, the U.S. lost the ability to independently carry astronauts into space and back to Earth.
Suddenly, NASA had to rely on Russian rockets and spaceships for manned space flights.
Without the shuttle, the Americans suddenly had no longer manned access to space, especially to the International Space Station. This was due to a decision made by U.S. President Bush in 2004, who said, "Dear NASA, from now on you will be flying to the moon and Mars. And because you can't do that with the shuttle, get rid of it. And you're building a new rocket for it, today's SLS. And by the way, the International Space Station will now be supplied by commercial companies, with financial support from NASA." This was referred to at the time as New Space. This would evolve into by far the most successful space company, Elon Musk's SpaceX, which with its Falcon 9 rocket finally brought dependence on the Russian Soyuz rocket to an end.
The flight of U.S. astronauts Robert Behnken and Douglas Hurley to the International Space Station in May 2020 aboard the SpaceX Crew Dragon marked a milestone. For the first time, a nation had entrusted its space travelers to a private company. The Demo 2 mission also marked the first manned launch from U.S. soil since 2011. After nearly 2 months in space, the two returned safely to Earth with the Crew Dragon.
Houston is go for undocking and departure.
Dragon is committed to undock.
For nearly a decade, American manned space travel had depended on Russia, an unacceptable situation for the superpower that once won the space race. In addition to SpaceX, other U.S. companies were also awarded contracts to develop spacecraft for manned missions.
Endeavor, on behalf of the SpaceX and NASA teams, welcome back to planet Earth, and thanks for flying SpaceX.
America has learned its lessons, and the lessons are, I need multiple providers. I want to have redundant capability. It's as simple as that. And that's meant that SpaceX is now also in this incredibly powerful role. But it also means that there are other providers as well. When it comes to space travel, America will no longer be dependent on a single provider.
The design of the SpaceX capsule also shows that a new era has dawned in the history of space travel. The touchscreen cockpit looks like a science fiction author's dream come true.
That's important to Elon Musk. Design is important to him. And not just design, but also the idea that the best part is no part. In other words, the part I don't need is the best part. It's becoming more and more minimalist, which also makes it easier. There are fewer sources of error. In other words, I'm going to leave out whatever I can leave out.
Less is more. With this principle in mind, SpaceX is also constantly developing and optimizing its Raptor engine, now in its third generation. SpaceX uses small engines that are produced in large quantities. This provides flexibility and safety. The number of engines used varies, depending on the application.
But you also have to remember that commercialization and the emergence of SpaceX as a successful company was only possible because NASA supplied the money and the expertise. The very original iteration of the first rocket engine, the Merlin engine, still flying today in an improved form in the Falcon 9, was originally developed by NASA. NASA developed this engine in the 1990s. Elon Musk then cleverly took over this development from NASA, brought it to market maturity, and developed it further. NASA provided engineers as well.
The use of multiple small engines was also designed to simplify the reusability of rocket stages, which was SpaceX's goal from the start. A large number of engines increases reliability and allows the precise kind of control that makes a safe landing possible. There are several advantages to multiple reuse of a rocket stage.
It dramatically increases your availability because you can launch again in a few weeks. So of course I can do more business and earn more money. But the next point, which is incredibly important, is that it gives you an opportunity to optimize the rocket. Suddenly, you can make the rocket perfect. And that, of course, enormously boosts your reliability.
The Falcon 9 is the rocket SpaceX used to make its vision of reusability a reality. A revolution in rocket construction that set new standards, enabling the young aerospace company to transform the market for booster rockets. And the breakthrough came with the Falcon 9, and SpaceX became the market leader in the satellite business. Contrary to the expectations of many space experts, Elon Musk's rocket strategy has paid off.
The concept of reusability was not considered credible at first. And I often heard people say, no, that can't work, it won't be sustainable. There's this or that technical problem that will make it impossible. Today, of course, we see things differently. It is a very clever concept that was tested. And that's exactly what SpaceX does, of course. Doing things that make logical sense, but haven't been tried yet technologically.
To Elon Musk, however, commercial success is only a means to an end. His goal is nothing less than to make humankind interplanetary, a human race that conquers and colonizes Mars. That is his plan, and he is investing a lot of money in it. The next milestone on this path is the Starship, currently the largest and most powerful rocket in the world. Starship is intended to open the door to the solar system, and will probably dominate the transportation of materials and people into space for many years to come. The entire system is designed to be reusable. And to quickly get the Starship and the first propulsion stage ready for relaunch, both return to their launch tower after use. A spectacular maneuver, once considered impossible, which SpaceX successfully demonstrates to the world's amazement. Starship is rapidly approaching series production. SpaceX is apparently decades ahead of the competition. NASA has also concluded contracts worth billions with other private companies. Boeing developed the final stage of its Delta rocket for large spy satellites, the Delta IV Heavy. It proved so expensive to launch, however, that it was used exclusively for government contracts and was eventually decommissioned. In 2005, Boeing and Lockheed Martin joined forces to form ULA, the United Launch Alliance. SpaceX was still in its infancy at the time and had a series of setbacks to contend with. This gave Boeing and Lockheed Martin a virtual monopoly on government contracts, and launch costs rose at a rate similar to ULA's rockets. Like SpaceX, Boeing also received a development contract from NASA for a manned spacecraft.
Ignition and liftoff of Starliner Atlas V.
The company was miles behind schedule, but in June 2024, the Boeing Starliner was finally launched into space, around 7 years late. There were 2 experienced NASA astronauts aboard, Sunita Sonny Williams and Barry Butch Wilmore. But the first manned mission was not successful. Problems with the propulsion system cropped up, and NASA decided not to bring its 2 astronauts back to Earth in the Boeing capsule.
Safety first, which is why it was decided not to fly back with this Starliner capsule, but to let it return empty and then bring these astronauts, who were still aboard the space station, back with the Crew Dragon space capsule at the next opportunity. And this decision was absolutely right. That's surprising, absolutely. Probably for the astronauts too. They were prepared for an 8-day trip and spent 8 months in space. I think it was a positive surprise for the astronauts because there's nothing an astronaut likes more than being an astronaut. So they're doing exactly what they were trained to do, and surprisingly for longer than planned. It happens to be their very favorite thing to do.
Separation confirmed. Starliner is now backing away from station and starting its return to Earth.
The Boeing Starliner returned to Earth without a crew. SpaceX was put in charge of the return flight for the 2 astronauts, an embarrassment for the traditional aerospace manufacturer.
Touchdown. Starliner is back on Earth.
New space. The commercialization of U.S. space travel, the awarding of contracts by NASA, and flights with tourists into space has created a new spirit of optimism around Earth orbit. The driving forces today, however, are no longer the traditional arms manufacturers and rocket builders, but rather super-rich individuals.
Initially, NASA turned to 4 private space companies to build spacecraft for the International Space Station. These included the old and experienced Boeing, but also the newcomer SpaceX. Elon Musk won the race. Boeing and their Starliner were not ready until 7 years later. Why? They ran into problems with the software. Valves jammed, parachutes didn't work. And to make matters worse, 5 of the capsule's engines failed on the International Space Station. A total of $1.5 billion in additional costs. NASA, meanwhile, concentrated on its new job, manned missions to the moon. The Europeans faced completely different problems. They needed a new means to access space. They pinned their hopes on the Ariane 6.
Europe had to wait a long time for this beacon of hope. The completion of Ariane 6 was delayed by 4 years. After the last flight of Ariane 5 in June 2023, Europe lost its own access to space. Ariane 6 will now close this gap, but it is not the answer to SpaceX's Falcon 9. With a payload of roughly the same size, the costs for Ariane 6 are higher than those of the private competition. SpaceX can also reuse its first stages. By contrast, nothing remains of Ariane 6.
Ariane 6 is a product, perhaps the last product, of the old approach to space travel, the way things were done in the past. An evolutionary step, not a revolutionary step. A disposable rocket in the classic sense no longer has a future on the free market. Price, availability, and dependability are what count. And I can address precisely these 3 points with a reusable space transportation system.
4, 3, 2, 1, top. Allumage de USSR, décollage.
The new European booster rocket launched into space for the first time in July 2024, successfully. And that is not a minor matter. There were around 40 first launches of new rockets from 2020 to 2024, and nearly half of them failed. So the chances of reaching Earth orbit on first launch were around 50-50. Still, problems did occur toward the end of the flight. The upper stage failed to reignite, so it could not be guided back into Earth's atmosphere to burn up as planned.
Séparation des USSR.
The rocket really did pull off a flawless first launch. The fact that the third ignition of the upper stage ultimately didn't work, and that the re-entry and the re-entry experiments didn't work, is irrelevant in my view. That was not the main objective of this launch. The main objective was to achieve a successful first launch. We're all happy about that. So in this respect, many European satellites will now be launched with Ariane 6 over the next few years.
By the time it was shown that rockets could be successfully reused, Ariane 6 had already been under development for a long time. That may make it the last European rocket of its kind.
When you stand beside this rocket the evening before launch and look up and down, you realize that it's all just for a few minutes. It's all just for this one flight, and then it's all gone. That's crazy. It's like being in a cathedral. It's like a church tower where the steeple is rebuilt for every mass. It's crazy. In terms of sustainability, there's no question that it's a good idea to reuse rockets.
Ariane 6 has given Europe back its own access to space, but there will probably not be an Ariane 7 developed in this form. The European Space Agency, ESA, is pursuing a strategic transformation.
In November 2022, the member states decided to design a new rocket type. The next rocket is not going to be an Ariane 7 as a further development of Ariane 6, but rather an entirely new rocket that we will purchase. The same way NASA buys Falcon 9 launches, we too will acquire rocket launches from commercial companies.
In the rapidly growing space business, the change of course towards privatization should make Europe competitive again. At the same time, the reorientation is meant to secure Europe's own independence in a time marked by geopolitical tensions. One specific initial project is to develop and build a reusable space freighter. This will not only deliver to new commercial space stations, but also ferry up to 2.5 metric tons of cargo safely back to Earth. The ESA has awarded development contracts to the Exploration Company, based in Planegg near Munich, and the Italian company Thales Alenia Space. Europe's main goal with the project is to gain the technological capability to re-enter Earth's atmosphere. As part of a second development stage, the contract also envisages a manned version of the spacecraft. Autonomous astronautical space travel is a long-held dream that European space policy has not yet authorized.
This ability to re-enter the atmosphere is, of course, the key technology. If you can bring 2.5 tons of cargo to the Earth's surface, then you can essentially bring astronauts back from the space station too. This decision has not yet been made. To date, the decision has been made to transport cargo. It's going to take a few transports to try it out and make it robust. But then this principle that the capsule can be expanded for astronaut flights will still require even more decisions to be made.
The space economy is a market with immense growth rates. Experts currently estimate its value at more than $600 billion. Around 90% of this is accounted for by space-based services such as communication, navigation, and Earth observation, while rockets and satellites comprise less than 6%. But this 6% is still required to generate the remaining 94%. As of 2024, there are around 10,000 active satellites orbiting the Earth. It's getting crowded in Earth orbit.
The more satellites you have, the bigger the problem becomes. All you have is a very limited resource in orbit, and not all orbits are equally useful. The first level you have to comply with is a certain level of regulation and discipline. So you have permission to do what's permitted and nothing else. There have to be rules that apply to everyone, and that are also considered fair, so everyone observes them.
The gaze up into space is realigning the world economically and strategically. More competition should mean more innovation and further reductions in cost. The coming end of the International Space Station will mark a turning point. Private and for-profit stations will take over its tasks in Earth orbit, with flying space hotels and, particularly, research laboratories in zero gravity for use by science and industry.
What do you want commercial space stations to accomplish? Research, the production of new materials, and very importantly, space tourism. And all of this, according to the NASA contracts, before the International Space Station comes to an end in 2030, when it will burn up in the Earth's atmosphere. And that will be the end of it. There's Airbus, for example, which will work with Mitsubishi to build a station called Thales. And Jeff Bezos, together with Sierra Space, plans to build a station called the Orbiter. Incidentally, Bezos has his eyes set on a business park with mixed-use areas. And then we have Axiom Space. They have a special contract from NASA. They intend to build a new space station, initially attached to the current space station, and then undock from it when the ISS comes to an end in 2030.
The private space company Axiom Space is already flying private individuals to the International Space Station as part of a collaboration with NASA. The company is also developing its own modules that will dock onto the space station for tourists and research missions and to train NASA astronauts. Axiom Space's goal is to have a space station of its own in orbit. The primary structures of the first test modules are already being built by the European space company Thales Alenia Space. Final assembly will then take place at Axiom Space in the US. The project poses an enormous challenge with high financial risk. In addition, it is not at all certain how long the ISS will actually be in operation and thus available to Axiom Space.
Our current assumption is that the ISS will be decommissioned in 2030. This means that these space stations will then be served by commercial providers, like commercially booking a large hotel room in space where you work and where you do your research. In the future, this will be offered by private companies, making this the new way astronauts will work in space, at least in low orbit.
There is an entire range of concepts for future commercial space stations. With the support of government space agencies, NASA first and foremost among them, these will create an opportunity for people to spend time in Earth orbit. Privately financed platforms for research and development, but also for space tourism. Vacation trips into space for multi-millionaires unfazed by the exorbitant ticket price. But this exclusive pleasure also comes at a cost to the environment.
It's physically impossible to get into space with a small rocket and little fuel. You always need these huge rockets that consume lots of fuel and that have to be produced beforehand. Nowadays, when we ask whether going on a cruise makes ecological sense, at least there's one thing you can say: flying into space is definitely the biggest ecological disaster you can cause.
At this point, the only permanently manned space laboratory still in state hands will likely be China's Tiangong Space Station, the name of which translates as Heavenly Palace. By placing the space station in orbit and constantly expanding it, China has shown that its ambitious space program is well underway. And so, in the 21st century, China has finally joined the absolute elite of spacefaring nations. This places them in direct competition with the US. The Chinese have also set themselves the goal of a manned return voyage to the moon.
China will play an increasingly major role in space travel in the years to come, until they catch up with the Americans in the early 2030s. And they have a very ambitious and detailed space program, which they have followed precisely up to now. This includes a lunar exploration program targeting a crewed lunar landing. And then they say that in 2033, they also want to land on Mars with a crew, and then do it again every 2 years. I think the Americans better get going. What have we achieved so far? We have a really nice scientific program, the International Space Station and the new James Webb Telescope. We're conducting unmanned exploration of our planetary system, and we're moving toward privatizing near-Earth space. But what is crucial, government space agencies are finally returning to what their mission should be, the conquest and exploration of space.
Space travel has changed fundamentally in the 21st century. After the space race of the 1960s and the construction of the International Space Station in the 1990s, the focus today has shifted towards commercialization. Government agencies are increasingly handing over low Earth orbit to private companies. After land, sea, and air, space has become the fourth domain in humanity's march of technical and economic progress.